We want to build waterflood models to compare the performance of our waterflood against some sort of reasonable standard. If we don't measure the performance of our waterflood, then the model building exercise is pointless. We have an opportunity to maximize the capability of our models to tell us important things about our waterflood by measuring a minimum number of variables. The ones that are included in this minimum are chosen by a trade-off between usefulness and cost. If we are interested in optimizing our waterflood, we have a choice between randomly trying new things or carefully setting up before and after measurements so that we can calculate the true value of a proposed intervention for our waterflood. The latter is, by definition, more expensive. However, by searching for and evaluating other ways of measuring the variables, we need to calculate our value add. The optimization itself becomes more efficient. Therefore, we can expect that the techniques described here will fall into three categories: stuff we do already, stuff we don't do now but may do in the future, and stuff we don't do now and are unlikely to do in the future. We may be tempted to think that the last category is a waste of time. However, the techniques that fall in this category vary depending on the waterflood, and they also depend on time. As a simple example, running a porosity log across the target reservoir on all new wells may have been nice, but ridiculous years ago. Now, not doing so requires an explanation.